In section 7, we're going to do some more problem solving, and here we're going to do some with distance, money, and interest. Now, in your booklets, they have this filled in already, but we're going to, again, ask you to write this up on the other side and develop a strategy for doing this type of problem. So step 1, of course, read the problem carefully. How long will it take a car traveling 60 miles an hour to overtake an activity bus traveling 45 miles per hour if the activity bus left 2 hours before the car? Okay. So they're suggesting in this chart, and I organized it a little bit differently, what is the rate of the car? Well, 60 miles per hour. Now, how long will the car be on the road? Well, we don't know that, so we'll call that time, t. I like the use of t. They use an x. Now, what's the rate of the activity bus? Well, 45. Now, what do we know about the time of the activity bus if t is the time of the car? Well, can you see from here it's 2 hours more. So this will be t plus 2. And what do we know about the distance? Well, we don't know the distance. But in a sense, if we multiply 60 times t, that is what the distance is, in a sense. And we know that when they catch up, one starting from here, one starting from here at a later time, the distance is actually going to be the same. So where we don't know the specific distance, we know that this distance equals this distance. And we know that this rate times time is distance. So this will equal 45 times t plus 2. Rate times time. And these distances are the same. Now, it is critical that we think of this time as a sum. So we have it in parentheses. So, in solving it, we're going to get 60t equals 45t plus 90. So we distribute that. Now we isolate the t on one side by subtracting 45t, which will give us 15t equals 90. So t will equal 6 hours. So the question is, how long will it take the car to reach the activity bus? And it's 6 hours. Now, how long were they on the road, or how many miles did they cover? What is this distance here? This would be 60 times 6, or 360. And this would be 8 times 45, which is 360. So this distance here is 360. Now, they're not asking us for that. In another problem, perhaps they might. But again, a diagram, they're going to meet together. The distances are the same. Rate times time is distance, and we equal them to each other. In example 2, this is a typical money problem where we have a collection of dimes, quarters, and nickels that are emptied from a drink machine. Now this was an error in the textbook. They had 4 here. So if we hadn't corrected that, scratch it out and put 2 there. There are 2 times as many dimes as quarters. There were 10 less nickels than there were quarters. If the total value of the coins was this, find the numbers of quarters, dimes, and nickels. Now, we're setting this up in that we don't know anything about the number of quarters. So I've left this, we're going to call that X. Now as you read it, there were 2 times as many dimes as quarters. So 2x, the number of quarters, times 2. And there were 10 less nickels than there were quarters. So the number of quarters minus 10. Now this is number of coins here. Number of quarters, number of dimes, number of nickels. Now here, what would be the value of a quarter? Well, it's 25 cents. What's the value of a dime? 10 cents. What's the value of a nickel? 5 cents. Now, what will be our value of quarters then? Each quarter is worth 25 cents, and this is the number of quarters. So it's going to be 0.25x. That's the total value of the quarters. And the same for the dimes. 0.10 times 2x, the number of dimes. And for nickels, x minus 10. So this is the value of the quarters, the value of the dimes, the value of the nickels. If we string them all together, we get our equation. And what are they worth altogether? $19.50. That's the year I graduated from elementary school. Wow, 65 years ago. Okay. Now what do we do? Well, we had said earlier, when there are decimals, one term, one term, one term, one term, multiply everything by 100, move the decimal place over. That will make our answer less complicated. And let's go from there. So I just distributed. Now we're going to combine like terms. We get 50x. I'm going to transpose this to the other side as a positive 50. Divide both sides by 50. I get x equals 40. So the number of quarters is 40. Now the number of dimes would be 2 times 40, or 80. And this would be 40 minus 10 is 30. And that checks out. Now in this example, we're using the formula interest equals principal times the rate times the time. And we have $80,000 to invest. But we're going to earn this much interest. But our principal here is divided into two parts. We're going to have part of it at 8%, part of it at 10%. So we have to think of a way to divide our 80,000 into two parts that we don't know how much is in each part. So we had from an earlier lesson said that if we take 80,000, we can divide part of it as x, the unknown part, and the other part as 80,000 minus x. Now here they want to find out how much did Jeff invest at 10%. So I'm going to set this up a little differently than what's in the book. So we're going to have this as the 10%, this unknown amount, because when we solve for x now, that'll be our answer. That's the 10%. And this amount, again, this is a sum, we have to put it in parentheses, will be the 8%. So a little differently, now you could do it the other way, as they show in our booklet, but this is another way to do it. So we'll start filling in the chart. So what was the percent of the principal invested at 10%, or with the amount? And we're saying that is x. Now, what was the percent? Well, we said again that was 10%. And the time is 1 year, so that doesn't change. So our interest will be 10% of this unknown amount. Now our 8%, the principal would be what's left over, the 80,000 minus x. And the rate of this is 8%. And this is just 1 year also, so we're going to get here 0.08. Let's write that in properly here. Times 80,000. Now, the total that we're going to get out of here, the interest we said was 73. And now we're ready to set up our equation, because it's principal times rate times time. Principal times rate times time is this, and that's going to be part of it. Then another part would be this, principal times rate times time is this, and eventually it's going to equal that. So our equation, we can write it up here. 0.08 times 8, 0 with 4 zeros, and I got to put the minus x in there here too. Jammed up for room a little bit. And then this one's easy, so it's plus 0.10x. Now here, notice we're going to add 2 zeros just as placeholders here until we move our decimals over by multiplying every term by 100. And then what do we get? And I'll put it on this side here. So 8 times this is 640,000 minus 8x, and this is just 10x equals this. So now I'm going to combine like terms, and I get 2x, And I'm going to subtract this now from that, and I get 90,000. Going to divide both sides by 2, and I get 45,000. Now, what did X stand for? Well, X stood for your 10%. So this is going to be 45,000. Now, they're not asking for the 8%, but you would subtract 45,000 from this and get 35,000. Now, if you did it the way it shows in the book, your X would have been 35,000. You would have had to subtract it from 80,000 to get the 45,000. But since we're designating our X as the 10%, as the algebra works, it gives us what we're looking for. So again, you'll have other problems similar to this. Hopefully this is a good model for you. Now I should mention, in many of these videos, up in the top here, you're going to have the letter I, if it's on YouTube. By clicking on that, you'll get to links that I've done in which we do additional exercises where I work out many more problems if that is useful for you. All right.